Welcome back to Arcade. I am Super Tommy. This is a series on creating a Sokoban or pushbox game in Phaser 3. Now, in the last part, we implemented multiple levels. So you can go from level 1 to level 2 to level 3. And we have our level service and our 3 levels here written in code as an array of arrays. So, and I mentioned that we're going to wrap it up in this video, but actually we'll probably need 2 more videos. We're going to do some sound in this video, and then we'll show you how to make some of the code more functional. Like I mentioned in a video before, we'll do some refactoring of this code to make it more functional. And then in the video after that, we're going to use tiled and make some levels in tiled that you can use instead of having to manage these 2D arrays and numbers. So first, let's get started with sound. So we have a music file called cave loop, and 4 sound effects. So now the cave loop is from opengameart.org. There's a lot of great free textures and music and all kinds of other things that you can find there. You just search for it when you get to the website. And then for the sound effects, we're using Kenny's great assets, including sound effects. And so we've taken these sound effects from digital audio, I believe, but he's got many that you can see here. So for our project, we are putting our assets in a public folder. So we've got them in public assets music, public assets SFX. So depending on your project setup, this may be a little bit different. I would just confer with your application bundler, your web dev server, your dev web server, or whatever tooling you're using. So to add music, let's do that first. We have this preloader scene that we've created. So let's preload our music file. So we'll do this .load.audio. We're going to call this game music. We only have one. We're going to call this game music, and it is located in assets, music, and it is called cave loop.wave. Fantastic. Okay. Now, we're going to play this music immediately. So this .sound .play, it's going to be game music, and we will want it to loop extra. Let's see what's in here. Loop true. So let's see if that works. You should be able to hear it. It's fairly loud, actually. Volume. Let's try half volume. Oops. Half. Still too loud. Quarter volume. How about 1/8 volume? It's probably still too loud. 1/10. I don't know what this is. 5%. Let's try this. All right, let's just say that's not bad. I'm gonna have to make it less loud. We'll go with this, 5%. Okay, so that's the game music we have, and the game should still work, right? Brilliant. Now we want a sound for click, so that's UI click confirmation. What does this sound like? Error, maximize. So let's see, how can I test this? We'll just play them in the actual game here. So we'll load the rest of this right here. Let's call this. We're going to load. We know what click is. How about confirmation 001? Nope. We just call this confirmation, and it's in assets, SFX, confirmation 001.wave. And then, just to test, we're going to do, well, this is actually going to go to game. Let's just say we've loaded it, and then we will play it in game to test how it sounds. Let's do it when the box lands on a color. All right, when it covers a color, we're going to play confirmation. So let's see, that's all targets colored. Get all the boxes, tween the move. Okay. Here we go. Covered target. Change target color covered count. Let's go into this method. Great. So we know if it's positive. Yes, so if change is greater than 0, because change can be negative, which means we are uncovering uncovering a target with box. So if it's positive, that means we are covering a target with box. This dot sound dot play confirmation. Let's see. So there we go. Now let's preload. So the sound should automatically stop playing once you unfocus from the browser. It's a UX thing, for the actual player playing the game, so that your music isn't blasting in the background in some tab that is no longer focused. I know it doesn't always work, but that is at least the intention of web audio in the browser. All right, so now maximize, so we're going to call this, I think this is move, and we're using this maximize 008 file for move, and while we're here, we're just going to load the error as well, and it's going to be assets sfx error 006.wave. Wave. See, sometimes it turns your audio off, not always, even though it was obviously not focused when it refreshed. I'm sure there's a reason for that in the logic for the browser, but that's how that works. All right, so now when we move the box, I'm going to call move. So here we go, moving the box, which is up here. So tween move, if there is box data, if there's no wall, and here we move. This is the end of the move, no? If box data, box at, let's see. Oh no, that was the negative. Yep. So now we start the move. We can just play this right here before the tween starts. You can do it after the tween starts too. I'm not sure it's going to matter. Since the tween, we call add tween here, but it will, the function returns immediately and then the tween plays over time. So let's see, move. So basically what I'm saying is this tween add doesn't block until the tween finishes. You're adding it, the tween's going to go, and then any code right after this tween's that add will continue or will be executed. There we go. Doot. 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 Beep. Okay. Yeah, their sound effects are better than mine. So now error. So error is if we try to move and there's like a wall. So for example, we keep pushing, or we keep pushing up there, it's error. So has wall is error, and if not box data, there's multiple places. So this is not super ideal that we're gonna put this in multiple places, but just for example purposes. So if there's a wall, we can move. If we're pushing a box and there's another box in front of it, we can't move. If we're pushing a box and there's a wall in front of the box, we can't move. All right. Doot, doot. Can't move. There we go. You can hear the error sound when we try to push into the wall. They can't move. All right, so that's pretty good. So now those are the sounds. That was pretty easy. We got all of ours except for the UI click. So let's actually do the UI click as well. This should be pretty familiar now. We've already done this load a few times. So load, audio, and then we're going to call this click. And it is an assets, sfx, click to dot wave. And let's see, we have a button and level finished. So let's go this dot sounds dot play or sound dot play click, and we're going to do it here as well. All right, let's see if we can properly finish this level. Okay, right, puzzles. I definitely don't memorize the solutions to these puzzles. Let's try next level. There we go. So the click definitely worked. Heard it. Let's see. Oops. Okay. It's definitely not going to be the optimal moves, I don't believe. Some of these sound effects may actually be too loud as well. Although I guess if I'm not talking over it, doesn't matter. Retry. You saw that click. You heard that click as well. All right, so that is the sound effects and the music. It was pretty easy. Now, before we wrap up this video, we are going to show you a functional programming method to refactor a code. So not always do we have to make methods inside our class. That's not the only way we can refactor code, nor do we have to make a new class, like in our level service. For example, we made a new class, and that holds all this level data. That's a very object-oriented approach, and one is not necessarily better than the other. It just depends on your preference, really, and some people say functional programming is better, some don't. I like both. I use whatever seems to fit the bill at the time. So one of the things in functional programming is you generally want functions to be pure. Now, a pure function is not going to mutate anything inside of it. Now, that is generally hard with games because you don't want to make copies of everything. It's not efficient to make copies of things and then return them, especially not in the update loop. But in certain cases, we can still do that as it helps us avoid errors from side effects that we did not intend. Unintended side effects or unintended mutations of variables that we pass into functions or methods can lead to bugs that you find hard to debug because you don't expect things to change when you call that function, but they change anyway. So let's see, what is a candidate that we have to do that? So this one I think is almost obvious since it returns true or false. There's no reason it needs to mutate anything. So what we can do is take this function. So now let's put a place for this function. Do we have a game folder? No. Files, levels. Yes, this utils folder may have been a bad idea from the beginning. All right, so we're gonna put another thing in and say no, not do that. Okay, we're gonna make a folder. And that folder, not inside utils, but we'll drag this out. We'll call targets. We're gonna drag it out to under source, right? Yep. Okay. And what we're gonna have here is a function called is all targets covered. .ts. Okay. So const is all targets covered. It's going to take what's the data structure we're using? Either a list or so this. Okay, so we need this, and we need almost an array, but two dictionaries effectively. So targets, what do we call it here? targets covered by color. So targets covered by color, which is going to be of this type. And then we will need to know boxes by color. Boxes by color. Okay. Now we're going to, of course, export. We can just do a default export. Export default is all targets covered. And so the logic in there is going to be the same as what we have in this class. We just don't need it in this class, right? So let's just take the body. We'll have to adjust this a bit. Let's collapse this. Boom. Okay. Now, basically, we can replace all the calls to this because there is no this. I mean, there is actually no, because we're using lambda, there's no this. In JavaScript functions, they do themselves have this. Okay, so we have that. So we can remove the calls to this dot boxes by color and this dot targets covered by color because we're passing it in. Right, so we're passing in this data that we need, and then this function is going to do the logic on it and then return us a result. Now, as long as we pass in the same variables here, as long as they have the same values that are being passed in, this function will always return the same value. So it's not going to like randomly, even if you run it multiple times, because it doesn't mutate anything, it will always return the same result. Now, so this we already have as a function of itself, this a function itself, target color to box color, which is here. It's in color utils, so target color to box color. Let's import that. So import from utils, color utils, and we want target color to box color. Okay. So let's just recap. So what we did is we took this all targets covered method from the game scene, right? This one, we don't actually need it to be part of the scene class, right? So let's just delete this. So now we have error because we are calling it here. And so what we're going to do instead, we no longer need this. What we're going to do instead is import the is all targets covered from targets is all targets covered. So that's the function that we made that does the same logic check, but it is outside of the scene class. Now I'm going to go here, and instead of this, we're going to do is all targets covered. We're going to pass it in the targets covered by color and this boxes by color. All right, so it returns the same Boolean value, except we are passing in the data that the function needs to give us a result. Nothing has actually changed. The logic is still the same, but we can move methods that don't really belong in this scene out of the scene into a standalone function. So now let's just give this a test. This is going to check that the level has finished. Boom. And so that is, of course, still worked. It still checks that all targets are covered. So that is a functional way to refactor code. You don't always have to make classes. You don't always have to move all your methods in you don't have to always break up your large methods in a class by turning them into other methods. You can compose them using individual functions where you pass in data that that function needs to do the work that it needs to do. And so that's it for this video. In the next video, we are really going to wrap up the series, and we're going to show you how to use tiled to make levels instead of having to use this text array system and remembering what the tile IDs are and then to lay it out like this. We're going to lay it out in tiled, load the tiled maps, and use those as levels.